So what we're going to do for these is, first of all, we're going to look and find out what it's generally going to look like. You see that this one's an x cubed graph. You know that it's going to act like a line going up from left to right. And the second one is a negative x to the 4, which is an even power. You know that this one's going to act like a parabola that goes down. So that'll give us an idea for what's happening at the end. If we want to find out right now some things of what's happening in the middle so we can get some points, for this first one, we can make, and you can always make, a table of values to find some points. That's sort of the most basic thing to go back for graphing. And I can tell you that some questions on the final exam, that is the best strategy for graphing. Even though you've learned, we learned all the transformation graphing skills, and we're going to learn more graphing skills in this unit, sometimes you come across a question that's stumping you and you don't remember how to do, a special shortcut. Go back to a table of values, because it's a great way to find some points and get a general shape for a graph. You can put in sometimes you put in some positive and some negative numbers. You can always add more. But let's say I do some negative numbers and some positive ones. If I plug in negative 2 cubed is negative 8. Minus 3 times negative 2 squared will be minus 12. This will give me minus 20. Negative 1 minus 3, this will be negative 4. Plug in 0, you get 0. Plug in 1. 1 minus 3 is negative 2. And plug in 2. 8 minus 12 is negative 4. So now when I go to graph this and plot some of these points, I have negative 2, negative 20. So 5, 10, 20. Negative 2, negative 20. I had negative 1, negative 4. I had 0, 0. I had 1, negative 2. And 2, negative 4. And I know that it wants to have this shape of a line. So looking at the points that I have right now, and we're not going to have a super accurate graph, but we're going to have an idea of what this graph looks like. It seems to be that it is coming from down here like it's supposed to, going through these points, just plain connect the dots. Now, I'm at this point, and if I would just continue, it would go down, and it would keep going down. But I know that my graph needs to look like a line. So I might even add another point here, see what happens if I do 3. If I plug in 3, I get 27 minus 27, I get 0. Okay, so it seems to be going back up again. And that matches with what the shape of the graph should be. How accurate is this graph? Not bad. I don't know if this is its maximum. Maybe I could go through these points, and I'll do it in a different color here. I could have gone through all these points and gone higher there and then lower like that. That would still be an okay sketch for right now. We don't know. It's a little bit messy, but we don't know exactly where it is. But we've done some points, and I made the graph go smooth through those points and get a general idea for the shape. Again, as we go on, we're going to learn more skills to make it even better. And then next year, you're going to learn all the skills with calculus, how you can really draw a graph like this accurately. So for part B, same idea. We're going to go to our table of values. X and Y. And plugging in these things aren't not super easy. I'm going to show you something with your graphing calculator, how you can get a table of values really easily. So what we're going to do is we're going to type this graph into our graphing calculator. Negative x to the power 4 minus 6x cubed minus 9x squared plus 3. I mean, your graphing calculator is really nice because you just push graph and it will graph it for you, and so you get the shape that way. So we know that our graph looks like that from our graphing calculator. We could plug in values for a table of values. The nice thing about an x to the 4 graph is if you had this on a quiz or a test, it would be calculator. So you would be able to use your calculator to see what the graph looks like as well. So that's kind of handy. And one of the things, if they ask for a table of values and you have the use of your calculator, instead of having to plug in negative 2 to the 4 and typing that all in over and over again, once I've typed it into y equals, above your graph button says the word table. And if you go second table, you will get a table of values. So if I want to see negative 2 is negative 1, here's my table of values. I can just drag it there. So you go to second graph, because above it, it says table. Okay? And inevitably, there'll be someone who in class decides to go down and go, I wonder how far I can get down before this class ends. And they get to like 850, and they're like, the next time that they go to their table, they're like, oh no, it starts at 850 again. And I just spent all class going down to 850, and now I want to get back to 1. There's good news. You don't have to click up 850 times. You can set your table right above window, right? You can, second window, second button. Trying that again. Let's try, there we go. Second window, there it is. Table start, it lets you pick where you want to start your table from. So if you want to find out what happens when I plug in 100, you can put 100 in for table start, and then when you go to second table, it starts at 100. It's already at some very large negative numbers. But you probably want to have your table start at 0. And then we have all of our values. So when we were graphing this, you would find out that at negative 2 you had negative 1. And I'll just look at where these points are on our graph. Negative 2 would be negative 1. That would be this point. Negative 1 would be negative 2, negative 1. That's this point, actually. My thing's a little bit off. 0 gave us 3. 1 gave us negative 13. So that'd be down here somewhere. Notice if I had just these 4 points, that it wouldn't have been enough to get an idea for the shape of the graph. So I might need a few more. But again, I wouldn't know how low to go or how high my graph will go. So if you have your graphing calculator, you can see the entire graph. And if you have your graphing calculator, you're going to see the different values and see what the graph actually looks like. Again, since it's an even-powered one, we know that it has to act like a parabola. And sure enough, this one is pointing down and opens down on both sides. So for this question, if you want to try some, 5, 6, and 8. And the other thing that you can do with your graphing calculator is you can figure out all of the important points using your graphing calculator. You could find all the x-intercepts. There's 4 of them with your graphing calculator. Do you remember what those are called? If you're solving for them, here's my graph. The zeros. So you go second trace, second trace. Number 2 is a 0. It says go to the left. then go to the right, and I'll put 2 arrows up at the top. And I'm going to find that one. And you'd have to go left and right for each of them to find all 4. The other thing your graphing calculator can find is it can find your local max and your local min points. Same place. Second, calculate. Number 3 is your minimum. Again, it asks you to go to the left. You can hit the left button over and over again. You can also type in numbers to go quicker. I can see that this minimum is between -3, or maybe -2 and -1. So I can just type in -2 and -1 instead of going left and right. And that's a little bit quicker. Push enter, and it finds that minimum for you. Okay, the questions you can do are 5, 6, and 8.